So Chapter 5 looks at polynomial operations and gets us ready to do factoring in Chapter 6, which has a lot of connection to Math 20-1, 20-2, and 30-1, and some into 30-2 as well. So it's a pretty pivotal chapter, these two. So in this unit, we're going to look at algebraic expressions called polynomials. This really should be a review from junior high algebra. We're going to classify polynomials, add and subtract them, multiply them. And then we're going to introduce the idea of multiplying two binomials, and then multiplying polynomials in general. So if we go back to a review, in algebra, a letter that can be used to represent a number is called a variable. We call it a variable because it can vary. Expressions like 2a minus b plus 4 or 5 over x plus 3 are called algebraic expressions because they contain these variables. So it's part of a whole branch of mathematics called algebra. And quite honestly, you've been doing algebra since grade 1. When the teacher looked at you and said, what plus 2 equals 5, and you figured out that it was 3, that's algebra. We just keep extending that. So just like in grade 1 where we dealt with things like 3 plus 5, and then by the time we were in grade 6, we were dealing with 5 and 25 tenths plus 3 and 79 hundredths. We just extend it and do more with these algebraic expressions. A monomial is the product of a number and a variable, or it could be the product of variables, or it could be just a variable in itself, or just a number. So all of these examples are considered to be monomials. The monomial has to have a positive, the exponent of the variable has to be positive in the numerator's position. So 5 over x would not be considered a monomial, because if I bring that x up to the numerator, it would become an exponent of -1. So monomials have to have positive exponents in the numerator. They can have a denominator of a coefficient. So this still is a monomial because I can have the denominator of 2. What I can't have is I can't have a denominator of x or a denominator of y squared. The number that comes in front of the variables we call a coefficient, a numerical coefficient. So in these, 6 is a numerical coefficient. -1/2, 25 hundredths, 2. What would be the coefficient here? Say it louder. 1. 1's the numerical coefficient. A polynomial is a group of monomials, the sum or the difference of monomials. It can be a monomial of itself, or I can have more than one term. If I have one term, I call it a monomial. If I have 2 terms, think of a bicycle, 2 wheels, it's a binomial. 3 terms becomes a trinomial because there are 3 separate terms. After that, we do not have specific names for 4, 5, 6-termed polynomials. We just call them a polynomial. Okay? The monomial, the binomial, and the trinomial are all polynomials. But if I ask you to classify the following polynomials and you write poly beside all of them, I'm going to mark it wrong. If it's 3 terms, it should be classified as a trinomial. If it is 2 terms, it needs to be classified as a binomial. So we're going to look at the following example. We're going to determine whether or not it is a polynomial. And we determine it's a polynomial by 2 things. We make sure that there's no variables in the denominator. And we also have to make sure that the numerical coefficient is a real number. So pretty much everything we're going to see is a real number unless it's something really outrageous like the square root of a negative number, which I can't do. That would no longer be a real number. We're going to determine whether or not the expression is a monomial, binomial, or trinomial. So if I look at A, 1/4 and 10, are those real numbers? Okay, so that's good. X and Y, are they in the numerator? So is this a polynomial? Okay, so this is a polynomial. What kind of polynomial is it? How many terms does it have? It has 2 terms, it's a binomial. So anything that becomes separated by a plus or minus now becomes a term. 1 term, 2 terms. So this I would label as a binomial. Okay, so look at the next one. Numerical coefficient, the number 3 is a real number, so that's good. With my variables, I need, go back up here, what does it say? It says that the exponent of any variable must be a positive integer. Is 1/2 an integer? Yes or no? No, integers have to be whole numbers, positive and negative whole numbers. 1/2 is not an integer. This is not a polynomial because q to the power of 1/2, this is not an integer. Okay, so let's look at C. Are the numerical coefficients, so the numbers in front of my variables, are they all real numbers? Yes. Square root of 7 is an irrational number, but it's still a real number. So I've met that condition. My exponents, are they integers? Are they positive integers?
Yeah.
So this is a polynomial. What kind of polynomial is this? Trinomial. There are 3 separate terms. Is D a polynomial?
No.
Why not?
Because the exponent is not an integer.
It has to have a whole positive number. And really, if we're talking about positive integers, we're talking about natural numbers. I could have an exponent of 0, so I could be talking whole numbers, but I cannot have a negative exponent. Is E a polynomial? Why not, Connor?
Variables in
The other way I could explain it is 7 over A. If I bring the A up, what happens to the exponent?
Negative.
Becomes a negative, so then this would become a -1, which then again, I cannot have a negative exponent. Okay? So there's a chart on the next page. I'm going to give you a couple of minutes. I want you to fill in the chart. So we'll do the first one together. In the polynomial expression 4x plus 3yz, how many different variables do I have? How many terms do I have? So if I have 2 terms, what would I call this polynomial? Okay. Okay, how many variables in the second one?
3.
How many terms?
3.
So this would be called a...
Trinomial.
How many variables in this one?
1.
Which one is it, 2 or 1?
1.
Why 1?
Because it has x and then x again is the same.
It's going to be the same. So if I substitute in for the variable, if I tell you that x equals 4, 4 is going to go into both of those spots there. So it's the same variable, just one has been squared and one has not. How many terms? 3. So what do I call this? Thank you. How many variables?
1.
How many terms?
1.
Colin, what do I call a one-termed polynomial? Thank you. And the last one, Taylor, how many variables?
2. 30.
Other Taylor, how many terms?
4.
Okay, so what do I call a four-termed polynomial?
Polynomial.
It's a polynomial. We have no special name for them after, well, there probably is, but we don't use special names for a four-termed polynomial. We just call it a polynomial with 4 terms. So in addition to classifying polynomials based on the number of terms, we can also determine or classify them based on the degree. The degree has to do with the exponents. So in 2x to the power of 5, what is the exponent?
5.
So the degree becomes 5. If I look at the second one, I have several variables all being multiplied together. So I look at their individual exponents. What's the exponent on A? 1. And I add them together. So this would have a degree of 6. That's when I have a monomial. When I have a polynomial, what I look at is each individual term. So what's the degree of this first term? 4. The 2 and the 2. What's the degree of the second term?
4.
The degree of the third term?
5.
What's the degree of the last term?
1.
Not 1. 0. If there's no variable, no degree. The degree has to do with the variable. So if there's no variable, there's no degree. Which of these numbers is the largest?
X to the power of 4.
So the 5 is the largest, so the degree would be 5. If a polynomial has a degree of 0, meaning that there's no variable present, we call this term the constant term because it stays constant. No matter what the variable is, it will always be this one particular value. So in this polynomial, what is my constant term? What's in front of the 2? So it would be, the constant term would be -2. Class example number 6 is a great example. Tends to show up a lot on quizzes and tests. Hint, hint. Because you have to think of the polynomial that matches these characteristics. Keep it simple. Don't try to get too fancy. The fancier you get, the more likely you could make a mistake. Give an example of a binomial of degree 1 in one variable. So if it is a binomial, how many terms do I have?
2.
Blank and blank. What comes between the 2 terms?
Math.
What math sign though?
Addition or subtraction.
Addition or subtraction? Pick one. Addition, okay. A binomial of degree 1 means the exponent has to have a degree of 1. So give me a variable.
X.
Does that have a degree of 1?
Yeah.
Yes. Okay. What do I put here?
Constant.
A constant. Can I put Q?
No.
Why not?
No.
No. Why can't I put Q here?
Because they only want one variable.
Because I can only have... So we're going to look at the basic property of a standard normal distribution curve. Everything under the curve will add up to 1. All the percentages put together will add up to 100%. I already talked about how it extends indefinitely to the left and the right. So this line approaches the axis but never touches it. It's symmetrical amount the mean, meaning 50% is on one half and 50% on the other half. All the data is represented by everything that's under the curve. So I'm not going to have a data value up here. They're all going to be underneath this curve. And the mean, median, and mode end up being the same value, which is right here. This represents the mean of the data, the median of the data, and the mode of the data. So a nurse records the number of hours a day an infant sleeps. Creates a normal distribution curve. What is the mean of this curve? Where's the middle?
12
What does that represent? 12 what?
hours.
So the baby sleeps on average 12 hours per day. What's the standard deviation? What am I going up by? 2. So the standard deviation becomes 2 hours. So with that knowledge, I want you to fill in what the values for A, B, C, and D are. So what are the values for A, B, C, and D? What's A?
6,
B,
8,
C,
16,
and D.
18.
So what are the percentage of days to the nearest hundredth does the infant sleep between 12 and 14 hours? So on my normal distribution curve, what percentage was within one standard deviation? Look on the previous page. 34 point, is it 13 or 09? Oh, sorry, 13. So 34.13 was right here, which is also right there. What did I have for a percentage within between 1 and 2 standard deviations? What was this percentage from the previous page? Pardon? And this one?
2.15.
So what percentage of the day does the infant sleep between 8 and 16 hours? So if I add all these together, that was within 2 standard deviations. You figured that out. 95.44%. What percentage of babies sleep for less than 6 hours a day? So if I have a baby that's sleeping less than 6 hours a day, should I be concerned? Yeah, because according to the statistics, less than 1% of babies sleep for less than 1 hour a day, or less than 6 hours. So if only like 0.1% of the babies sleep for less than 6 hours, and I have a baby that's sleeping for only 4 hours a day, I definitely should be concerned. Because babies aren't supposed to sleep just 4 hours a day. Likewise, if I have a baby that's sleeping 20 hours a day, I should be concerned for the same reason. Because again, less than 1%, like barely 0.1% of the populations of babies sleep for more than 20 hours a day. But everything else could be considered within that normal range. Can you tell me what percentage of babies sleep for less than 13 hours a day? Yes or no?
Wouldn't it be 34.13?
Where's 13?
Maybe a little bit 14.
But if I draw this up, does this split the 34.13 in half? Not really. So can I determine the percentage? No. Why not? Because it's in between standard deviations. There is a way of determining that. And that's what we're going to work through next. We probably won't get done the lesson today. We'll have to finish it tomorrow. To solve this, we use the concept of z-scores. So there has to be a way of determining percentages that are within the standard deviations. I can't just keep everything between 0 and 1, or 1 and 2, or -1 and -2. I have to be able to find those that are part way. So a z-score for a particular data value is the number of standard deviations the data is above or below the mean. So if I look quickly at this diagram, 13 is how many standard deviations above 12? This is one standard deviation. If 2 hours is one standard deviation, what's 1 hour? 0.5. So this would be 0.5 of a standard deviation above the mean. If I wanted to know about 9 hours, 9 hours is how many standard deviations away from 12? 1.5. And because it's below, it would be a -1.5. So if we look back at the previous class example, the data value of 18, and we have the nice chart below that we can look at. So 18 is 1, 2, 3 standard deviations above the mean. So it would have a z-score of 3. 8 is 2 standard deviations below the mean, which means its z-score would be -2. How many standard deviations is 12 away from the mean? Pardon? 0, because it is the mean. So it is no standard deviations away from the mean, so its z-score would be 0. And then 13, as we talked about before, is half a standard deviation above the mean. So the z-score would be 0.5, or 1/2. So if I look in terms of mu or in terms of the mean and the standard deviation, we did this already, where we said this was 1 standard deviation, 2, and 3. And then going backwards, we subtracted. And then if we convert all of those to z-scores, there are my numbers. So with that information, how can I calculate a z-score for 13? Well, the z-score for 13 would be 0.5. But what if I wanted a z-score for 13 and a half hours? 0.75. What if I wanted a z-score for 11.3 hours? Starts to become a little bit more complex. Okay? That's why we have a formula. To calculate the z-score, we take the data value, so in our 13 example, 13 minus the average of 12 divided by the standard deviation of 2. So if I had if I had 11.3, it would be 11.3 minus 12 divided by 2. That would give me my z-score. When the z-score is positive, it tells me it lies above the mean. If the z-score is negative, it is below the mean. So I think I'm going to do one more part, and then we'll call it the end of this part. In this table, there's a rule that is sometimes referred to as the 68, 95, 99 rule. 68% of the data is within 1, 95 within 2, and approximately 99 within 3. So it's a good approximation. Approximately 68.3% of the data lies between a z-score of -1 and +1. 95.4% of the data would lie between a z-score of and 99.7% of the data lies between what two z-scores? So what I want you to do tonight is I actually want you to do questions 1 and 2. So do questions 1 and 2 first, and then we can continue on with the rest of the lesson. So to continue with lesson number 3 on the normal distribution, we're looking at using the z-score formulas. So the z-score formula is basically a way of telling me how many standard deviations above or below the mean I'm now at. So the heights in centimeters of 5 starting members of the Wolfhounds basketball team are 170, 182, 193, 195, and 210. If the mean height is 190 and the standard deviation is 15, calculate the z-score for the tallest player. The calculation for the z-score for the shortest player is shown. So x refers to the data value that you're given. Mu is the average of the data set, and then sigma is the standard deviation of the data set. So 170 minus 90, which is -20, divided by 15 gives me -1.33 to the nearest 100. If I look at the z-score for the tallest player, what was the height of the tallest player?
12.
So if I use this formula, the x value is 212, the mean is 190, and the standard deviation is 15. So if I go to put this into my calculator in one step, I want to make sure I have brackets here. So grab your calculators and tell me what that would equal. 212 minus 190 divided by 15. Yes, Matt?
I forgot my sweater in the other room. Can I go get it?
Yes.
Your batteries are low. Yeah. 199.222.
199? Did you divide? I would double check that. Pardon me?
1.46.
What's after the 6?
666.
So if I go to round this to 2 decimal places, the 6 would become a 7. So what it means is that the tallest player is just about 1.5 standard deviations above the average, whereas the shortest player is about 1.3 standard deviations below the average. Now, class example number 4 is an example of how z-scores can be used to compare your classes.
Yeah.
So when you get your report card and your report card gives you your marks,
Take that out.
and it says that you've got an 85 in math, but you've got like a 75 in physics, Is your math mark really better than your physics mark? If I convert everything to Z-scores, then I can come up with an accurate representation. Because if the class average and the standard deviation is such that in the physics class, my mark of 70 is actually much more or more standard deviations away from the mean than my math mark of 80, I might actually be performing better in physics than in the other class. So these are Tony's midterm marks for the subjects, math, chem, and physics. So you've got Tony's mark, the class average, and then the standard deviation for each course. So if I calculate his Z-score for math, it would be his mark minus the mean divided by the standard deviation. So take your calculator and tell me what is 74 minus 68 divided by 4 or divided by 12.
68.3.
How much?
68.333.
Okay, try that again.
You have to put
But
that.
go bracket 74 minus 68 bracket divided by 12.
0.5.
Okay? I want you to do the same thing for his chem and his physics marks, please. So if we look at Tony's chem mark, the Z-score for chem would equal, so what would I write on the top for my formula? Divided by, and what does that equal?
0.425. 428.
So 425, so 43 then? Okay. Now his physics mark. Which equals
0.1817.
So looking at the Z-scores, which class is Tony actually performing better in? Math. This is his best class. Because in chemistry, he's half a standard deviation above the average. Whereas in chem and physics, he's less than half and he's only at like 2/10. So even though his math mark is lower than his chemistry mark, because of the class averages, it affects where he sits in the class. The class average in chem is higher than math, so his Z-score ends up being higher in math. So in class example number 5, 6, and 7, we look at solving for the other variables in the Z-score formula. So my Z-score formula is x minus mu divided by sigma. So the average mark on an English exam was 63 and the standard deviation was 12. The marks are normally distributed and a student's Z-score was 1.5. What did they actually get on the test? So if I go back through and I look at these numbers, 63 corresponds to which of these 4 variables?
What? That's not right.
12 corresponds to the thing on the bottom, we call it sigma. And 1.5 corresponds to the Z-score. So it's x that I don't know. So I want to get x by itself. So to get x by itself, the first thing I want to do is get rid of this 12. How do I get rid of the 12? Multiply both sides by 12. So what is 1.5 times 12? What'd you get, Courtney? 18, thank you.
48.
How do I get rid of the 63?
Yes.
So what is 63 plus 18?
But did you
How
get
much?
the right answer?
81.
So the actual mark was 81. Okay, the next question. So again, I start off with my formula, z equals x minus mu divided by sigma. The weights of a large shipment of cantaloupe are normally distributed with a mean of 2.3 kilograms. The weight of a particular cantaloupe is 1.7 kilograms, which is 1.01 standard deviations below the mean weight. Determine the standard deviation to the nearest hundred. What's x? What's the value of x in this question? Pardon? In this question? In the cantaloupes, what's x?
Would it be 2.2 kilograms?
What does 2.3 tell me? What does it say about 2.3?
Oh, with the mean.
So 2.3 would actually be the mu.
No, but like this.
What's x?
1.7.
Standard deviation is what I'm asked to calculate. What's my z-score?
Is that what we're trying to figure out?
No, I'm asked to figure out the standard deviation.
Yeah. So it's 1.2
What words in the question tell you that that's the z-score? Because it doesn't actually say the z-score is 1.01. What does it say? It says it's 1.01 standard deviations below the mean weight. Remember, z-score tells me how many standard deviations I am away from the mean. Now, if I'm below the mean, what should my z-score actually be? How do I know if a z-score is above the mean or below the mean? Because one standard deviation could be above or it could be below. What do I use to differentiate between the ones that are above and the ones that are below? So the word below the mean weight means that my z-score has to be a negative 1.01. If sigma is on the bottom, I need to bring it to the top. So to do that, I multiply both sides by this sigma. So I will get negative 1.01 sigmas equals, what's 1.7 minus 2.3?
Negative
6, sorry. How do I get rid of the negative 1.01 on this side so I'm left with just sigma? So negative 0.6 divided by negative 1.01 would equal 0.59. What's after the 9?
4.
So to the nearest hundredth, 0.59. That becomes my standard deviation. Now, your standard deviation is always going to be a positive value. Standard deviation talks about the disbursement of the data around the mean, and it does not look at it as being a positive or a negative value. Okay, the last question. The marks on a math exam at a university are found to have a mean of 52 and a standard deviation of 12. So that means within one standard deviation, which was 68% of my data, that chart, or that curve that said it was 68, 95, 99, that means 68% of the marks in my class were anywhere between 40% and 64%. Professor thought that maybe this exam was a little too difficult, So he adjusted the original marks. He changed the mean to a 65 and then reduced the standard deviation to a 10 and left the z-scores unchanged. And then used the z-scores to calculate the new course or the new exam mark. So what would the new mark be if the original mark was a 34? So the first step is I need to find out what the z-score of a mark of 34 was on the original exam. So that's my x minus mu divided by sigma. So I'm going to give you a moment and I want you to use the original marks, the original mean, the original standard deviation to determine the original z-score. So how did you calculate this?
34 minus 2 divided by 12.
And what do you get?
Negative 1.5.
So that becomes the z-score for my new mark. So my new mark, which is x, the z-score remained unchanged. So the z-score becomes the z-score in my new calculation. The mean was changed to a 65, and the standard deviation was changed to a 10. See if you can solve that equation for me. So what's the first thing that you would do to solve for x?
You gotta bring the 10 up.
Okay?
Then equals negative 50. Then you gotta add 65 together. Just get everybody else. And then you get 50.
So he now has a mark of 50% instead of a mark of 34. This is done. And it's not even just necessarily done at a university. Marks can be adjusted using this type of method. So I kind of keep everybody's z-score or the distance away from the mean the same. So I'm not necessarily elevating everybody's mark by 10%. I'm taking into consideration where they are in relation to the average set. So the questions that I want you to work on are these ones. 4, 5, 6, and 7, practice solving for the various variables within the formula. And then 10 to 12 are some problem solving.
Yeah, exactly.